Okay, let's dive straight into something that really makes you question everything you think you know about the universe. The possibility that we're living inside a black hole.
Wow. Yeah. Sounds like pure sci-fi.
Totally. But this is exactly what we're going to unpack today. We got the idea from a really fascinating conversation with Mariana Maus on Granmisterio Podcast. One of you actually shared it, so thanks for that.
It's amazing, isn't it, how this seemingly, way out there idea of a black hole universe might actually offer some pretty intriguing angles on some huge cosmic puzzles.
Like what specifically?
Well, things like the origins of those supermassive black holes. The ones smack dab in the center of galaxies.
Right, where did those come from?
Exactly. And the mystery of the Big Bang itself. Plus, maybe even why galaxies tend to spin the way they do.
Okay, yeah. So our jumping off point is that YouTube discussion. It was a real exploration of cutting edge science, those astronomical mysteries that make your head spin, and some of the more, let's say, unconventional theories that really get your mind racing.
And Mariana Maus, the guest on Granmisterio. Her background's interesting too.
Yeah, paranormal podcasts,
Yeah.
which I find fascinating, actually. It shows how that basic human curiosity about the unknown, it can lead you down all sorts of paths, even into cosmology.
It certainly highlights how we approach these fundamental questions about existence. Her background brings a slightly different perspective, kind of sitting at the intersection of established science and more imaginative exploration.
Right. So your mission for this deep dive, and you've already accepted it just by pressing play, is to really get to grips with the core arguments for this black hole universe theory.
Yeah, we want to see how it potentially explains some of those cosmic head scratchers.
Think of it as a chance to look at the universe and maybe even our own beginnings in a completely new light.
And stepping back, looking at the bigger picture, what we're really doing is pushing the boundaries of our current understanding. These are ideas that challenge some really basic assumptions about reality.
Okay, let's plunge right in then. The black hole universe theory. The main idea, as Mariana discussed, is that our entire observable universe isn't just near a black hole, but actually inside one.
It immediately makes you think about those supermassive black holes, right? Lurking in galactic centers. Where did they come from?
And what's really thought-provoking is the parallel between how black holes form collapse and explosion of massive stars.
Right, supernovae.
And the Big Bang. Our best explanation for how our universe began both seem to involve a kind of initial explosion or, rapid expansion.
Exactly. And inside a black hole, you have this concept, the singularity.
The singularity, right? Imagine all the stuff from a star squished down into this incredibly tiny point, smaller than anything we can really wrap our heads around.
And at that point, our current laws of physics, as we understand them, they just kind of break down.
What's beyond it? Total mystery.
And that unknown is where this theory really takes off. Think about a black hole in basic terms.
Okay.
It's a region of space-time. Gravity's so strong, nothing escapes. Not even light.
And that's because of escape velocity.
Right? Exactly. You throw a ball up, the faster you throw, the higher it goes. Escape velocity is the speed you need to escape Earth's gravity entirely. In a black hole, the gravity's so intense, the escape velocity is actually faster than the speed of light.
Which light can't do, so it's trapped.
Precisely. Now here's where it gets really interesting. Mariana brought up the James Webb Space Telescope.
Ah, yes. What did Webb see?
Well, apparently a significant chunk of the galaxies Webb's observed, over 60%, show this tendency to spin in a particular direction.
Huh. Not random then. A preferred spin.
Seems like it.
Yeah.
Which suggests something way back at the beginning of these galaxies gave them this initial spin.
Okay, and the connection.
Well, guess what? A black hole, especially a rotating one, has its own spin.
Yeah.
Scientists call it angular momentum. Could that primordial spin, the spin of the parent black hole, have been imprinted on a universe born inside it?
Whoa. Okay, that observation is definitely a tantalizing piece of the puzzle.
If you picture a rotating black hole, it just naturally has this angular momentum, this spin. It's not unreasonable to think a universe starting inside it might inherit that initial rotation.
And then there's a great attractor.
Ah, yes. Another cosmic puzzle.
This mysterious region out there in our observable universe. And it's pulling everything towards it. Galaxies, galaxy clusters, the whole shebang.
Yeah, scientists aren't totally sure what it is. Massive concentration of galaxies, maybe.
Yeah.
Something more exotic.
But Mariana pointed out an interesting parallel. Could the dynamics within a universe inside a black hole have its own version of a great attractor? Some concentration of mass or energy shaping the structure inside?
It's a very thought-provoking analogy. I mean, the great attractor shows our universe isn't uniform. There are these huge structures and movements we're still trying to figure out.
So the black hole universe theory gives a potential framework for explaining some of that.
It offers a potential framework, yeah, for some of these large-scale features.
Okay, so if we are inside a black hole, what happens to all the stuff that falls in? Mariana touched on this idea that information isn't just lost.
Right, this is a key concept, black hole physics. There's this idea called the holographic principle.
Holographic, like a hologram.
Sort of. Imagine a credit card flat, 2D surface, right? But it stores a surprising amount of information about you, your account.
Mm-hmm.
The holographic principle suggests something similar for black holes. All the information about the matter that falls in might actually be encoded on its surface, its boundary.
The event horizon.
Exactly, encoded on the event horizon.
Okay. And this connects to Jacobo Grinberg's Synergica theory, this idea of a universe-wide information network, the LIZ.
Yes. Mariana made that fascinating connection. Could the event horizon of our black hole universe be the source of this universal information network?
Like all the information making up our reality is somehow encoded on this boundary.
It's intriguing, right, how these seemingly unrelated concepts, the physics of information at black hole horizons and these more maybe philosophical ideas about interconnectedness might actually link up.
If the event horizon acts like a giant information processor.
It could potentially be the origin of such a universal network, yeah.
Okay, let's shift gears a bit. Mariana brought up a really interesting point about consciousness, technology, and aliens.
The ET question.
Yeah, she questioned why we always assume advanced civilizations would use technology like ours. Radio waves, stuff like that.
That's a crucial point. Our own tech development, it seems advanced to us, but cosmically speaking, it's brand new.
Blink of an eye.
Exactly. It's entirely possible that civilizations millions, maybe billions of years older than us, they might have evolved beyond needing what we think of as technology.
She used a great analogy. Only about a 1% DNA difference between us and chimps, right? Yet look at the technological gap. We built the James Webb Telescope. Imagine a 10% difference. Or 50%.
If tiny biological differences lead to such dramatic divergences, it seems pretty limiting to just project our current tech onto vastly older, maybe vastly different intelligences.
Which led to this really cool idea. Maybe super advanced beings could interact with space-time itself.
Right, not needing physical machines for observation or travel.
She mentioned Miguel Alcubierre's warp drive theory.
The Alcubierre drive. Theoretically possible, based on general relativity.
The idea is basically bending space in front of a ship, expanding it behind, creating a warp bubble.
Yeah, so you travel faster than light relative to the space outside the bubble. But inside the bubble, you're not breaking any local speed limits. You're kind of surfing on a wave of space-time.
It's still theoretical, but it shows there might be ways to get around light speed limits by manipulating space-time.
It hints at a level of technological or maybe even biological mastery that would seem like magic to us.
And then Mariana speculated, maybe civilizations starting inside black hole universes could find ways to actually exit, travel between them.
It sounds like wild sci-fi, but within this theoretical framework.
It's a logical next step to consider, right?
If our universe is inside a black hole, which itself is part of some larger structure, then maybe the event horizon isn't totally impenetrable.
Not for someone sufficiently advanced.
Conceivably, yeah. They might discover or even engineer pathways through it.
This connects nicely with that diffusos theory she mentioned. These incredibly advanced extraterrestrial entities. What's that about?
The diffusos theory, as Mariana explained it, suggests being so advanced they've learned to manipulate space-time to an extraordinary degree.
How so?
They might create protective bubbles around themselves, effectively isolating themselves from the normal flow of time.
So, imagine the universe goes through cycles. Big bang, expansion, maybe a big crunch or big rip. These diffusos inside their time bubbles could just float through it all, independent of cosmic events.
That's the idea. Experiencing something like a timeless existence, giving them unimaginable amounts of time to evolve.
Wow. So they'd be incomprehensible to us.
Pretty much. The theory even suggests that maybe the huge empty voids in the universe aren't empty at all. Maybe they are the diffusos.
Okay, mind blown again. And the connection back to black holes.
Well, black holes could potentially be these temporal bubbles, natural hiding places. where these advanced beings are shielded from the rest of space-time.
Highly speculative, obviously.
Of course, but it offers a totally different way to think about black holes and what might exist inside or around them. It tries to reconcile the vastness and apparent emptiness of space with the possibility of super advanced life we just can't detect.
Okay, on a completely different scale. Micro black holes.
Yeah, tiny ones. Theoretically possible, maybe remnants from the early universe, size of a grain of sand, maybe smaller.
Mariana mentioned simulations. What if one passed through you? Sounds bad.
Theoretically. Probably nothing significant, because they're so incredibly tiny, they'd likely pass right through without causing much physical damage.
Really?
But they would theoretically leave a tiny, potentially detectable trace of energy. So maybe not completely unnoticed.
Okay, shifting focus again. Something more observable, but with future implications. The diminishing observable universe.
Right, because the universe's expansion is accelerating. That afterglow of the Big Bang, the cosmic microwave background radiation.
EMB.
It's gradually getting fainter,
Yeah.
more stretched out, redshifted.
And Mariana pointed out that future civilizations, maybe billions of years from now, they might not be able to detect it at all.
It's possible.
Huh.
Which could limit their understanding of cosmic origins, maybe even some fundamental physics. They wouldn't have that key piece of evidence we rely on.
That raises a really interesting point about scientific progress, doesn't it? Our understanding is built on what we can observe right here, right now.
Exactly. Future civilizations might develop totally different ways of understanding the cosmos based on what they can see in their era.
Which ties back to what we said earlier. Maybe different civilizations perceive reality fundamentally differently anyway, not relying on light or radio waves like us.
Our reliance on the electromagnetic spectrum might just be a narrow window. Other ways of sensing or interacting with reality might be possible for advanced intelligence.
Okay, this next one is really mind-bending. From ufology, demonic reality. What on earth is that?
It's this idea that some unexplained phenomena, UFOs, maybe even mythical creatures, might not be external physical things in the way we usually think.
So, not actual aliens or monsters?
Not necessarily. Instead, they could be projections from our own collective consciousness, shaped by our beliefs, our expectations, our fears.
Mariana used the Fatima apparitions as an example.
Yeah, a fascinating case. Initial accounts describe like a small floating sphere.
Okay.
But over time, through cultural interpretation, it evolved into the religious figure of the Virgin Mary.
So our minds shaped the perception.
That's the idea. It shows how our minds can take something ambiguous and interpret it through our existing cultural lens, giving it meaning that maybe wasn't inherent.
And this connects to alien encounters. Like, why are aliens so often humanoid?
Exactly. Given the potential diversity of life, why the 2 arms, 2 legs, big head, the daimonic reality idea suggests maybe their appearance is tailored, consciously or unconsciously, to our expectations, a sort of cosmic mirror.
So if advanced beings understand our psychology,
they might choose to interact in ways we can comprehend, even if their true form is totally different.
Which implies maybe they choose when and how to reveal themselves. It's not just random chance.
It suggests a level of awareness and control on their part, yeah.
Sure.
Consistent with highly advanced intelligence.
Okay, changing gears again. Origin of life. Panspermia.
Right, the hypothesis that life's building blocks, or maybe even simple life forms, can travel between celestial bodies.
Wow.
Carried by meteoroids, comets, maybe even spacecraft, theoretically.
Mariana mentioned material being exchanged between planets, like rocks blasted off Mars by impacts landing on Earth.
It definitely happens. We've found Martian meteorites on Earth.
Which raises that possibility. Maybe life on Earth actually started on Mars?
It's plausible. Early Mars might have been more habitable than early Earth. If life started there first, it could have hitched a ride here on one of those rocks after Mars lost its atmosphere.
And then she mentioned that really controversial report about octopuses.
Ah, yes, the octopus paper. Suggested they might have extraterrestrial origins, maybe via a virus delivered by meteorite.
That sounds pretty wild.
It definitely sparked a lot of debate, but it highlights how we should maybe be open to unexpected, even non-terrestrial influences on life's evolution here. Pushes the boundaries.
Okay, time travel. Classic sci-fi trope. Mariana brought up the grandfather paradox.
The old classic. Go back, prevent your grandparents from meeting. So you're never born, but then who went back? Creates a contradiction.
Right, a logical impossibility in a single timeline.
Which is why a common solution proposed is alternative timelines, parallel universes.
So when you travel to the past, you don't change your past.
You create a new branch, A different timeline where events unfold differently because of your actions. Your original timeline remains unchanged.
That resolves the paradox, kind of. Mariana used that fun example, the giant particle, referencing Zelda and Back to the Future.
Yeah, the Song of Storms, Johnny B. Good thing, illustrates causal loops.
Where an event in the past seems caused by the future, which depends on the past. Like a chicken and egg problem with no clear start.
Exactly. It messes with our linear sense of cause and effect. Where did the song originally come from? It's impossible to say in that loop.
And she had that analogy, an open portal to the past in a city square.
Right. People stepping through aren't changing their past. They're stepping into a new version of the past, which then evolves into a new, different future. Branching timelines.
Okay, now let's bring black holes back into the time travel chat. Mariana suggested these potential connections between universes via black holes. They might be pathways to these other timelines.
Within that multiverse framework, yeah. If our universe is one of many, maybe black holes are the bridges, connecting different universes, each representing a different evolution of reality, a different timeline.
So it wouldn't be like jumping to a totally separate universe with completely different physics.
Maybe not. The idea is these connected universes might share some fundamental similarities, maybe the same basic physical laws because they're linked, perhaps from a common origin.
Making travel between them, while still incredibly hard, may be more conceivable than reaching a totally unrelated reality.
Perhaps. It suggests a more structured multiverse, potentially navigable via these black hole connections.
So maybe super advanced beings use black holes not just for getting around our universe, but for inter-universal, inter-timeline travel.
If it's possible, it could certainly explain some phenomena that seem to defy our current understanding. The possibilities are just staggering.
Okay, let's dive into the quantum world, the double slit experiment.
The classic illustration of quantum weirdness, wave-particle duality.
Right, particles like electrons act like waves when you're not looking, going through both slits at once, creating an interference pattern.
The moment you try to observe which slit they go through.
They snap into behaving like particles, go through only one slit, no interference.
The act of observation changes the outcome. But here's the really weird part Mariana highlighted.
The distance thing.
Yeah. Imagine setting up your detector really, really far away. The particle seems to know instantly that it's going to be observed even way down the line.
So it behaves like a particle right from the start, even before it reaches the detector, like it changes its own past.
It appears that way. It suggests this spooky action at a distance, non-locality. The measurement now seems to influence the particle's state back then instantaneously, regardless of distance. It messes with cause and effect.
Which leads into John Wheeler's idea, the participatory universe.
Wheeler's concept, yeah. The idea that our act of observing the universe isn't passive. We're actively involved in shaping the reality we perceive.
We're not just watching the movie, we're somehow helping create it.
In a way, yes. Wheeler suggested the universe might only click into a definite state when it's observed by a conscious observer. Before that, it might exist in a haze of probabilities. We are, in a real sense, participants in creating reality.
Mariana used that image.
Yeah.
An eye observing the universe being created. Kind of like the Eye of Providence symbol.
It's a powerful visual. The eye symbolizing consciousness and observation, being central to reality solidifying. Without observation, maybe reality remains fuzzy, undefined.
The implication is just mind-blowing. We, just by looking, might be part of the universe's existence.
It really blurs that line between observer and observed. Suggests a much deeper connection between consciousness and the cosmos that we usually think about.
Okay, one last really speculative idea. Pashans and the Big Bang.
Pashans, hypothetical particles. If they exist, they'd always travel faster than light.
Which means they'd travel backward in time.
Theoretically, yes, based on relativity. Though they come with a host of theoretical problems and paradoxes, and we've never detected one.
But the really wild theory Mariana mentioned, Tachons might have caused the Big Bang?
Yeah, by traveling backward in time from the future. Imagine them popping into existence after the Big Bang, traveling backward and converging at the initial singularity, effectively triggering it.
So the beginning was caused by something from later.
It completely flips cause and effect. A very unconventional, highly speculative idea suggests the start of the universe might have been seeded by particles from its own later stages. Truly bizarre.
Okay, last stop. Wormholes. Sci-fi loves them as shortcuts through space.
Right. And they are theoretically allowed by general relativity. Einstein-Rosen bridges.
But they're not simple tunnels like in the movies.
Probably not. More like a sort of window connecting two distant points. And the bigger issue is stability.
They collapse instantly.
Most theoretical models suggest they would, pinching off faster than anything, even light, could get through. Unless
you could prop them open somehow.
Exactly. That's where exotic matter comes in. Hypothetical stuff with negative mass or negative energy density.
Negative mass, so it repels gravity instead of attracting.
Essentially, yes. Its weird gravitational properties could theoretically counteract the collapse, holding the wormhole open.
But we've never found exotic matter.
Nope. Doesn't mean it's impossible, though. And Mariana pointed out, maybe advanced civilizations could create or manipulate it.
And if they could?
Controlled travel through wormholes becomes a possibility, connecting vast distances, maybe even different universes.
If these connections exist, what might come through from another universe? What intelligences might be watching us? It's a lot to wrap your head around.
It really is. These are the questions that push the boundaries, ignite the imagination, reminds us how much we still don't know.
Absolutely. So just to quickly recap some of the really mind-bending ideas we've hit on. The possibility of our universe being inside a black hole, information being key at the event horizon, consciousness maybe evolving beyond tech, those mysterious diffusos.
Panspermia spreading life, time travel paradoxes and timelines.
And the participatory universe, us shaping reality by observing it.
They're big ideas, many still theoretical, but they offer different ways to think about the deepest mysteries, encourage us to look beyond our limits.
Okay, so here's a final thought for you to chew on. If our universe is inside a black hole, what could possibly lie outside the event horizon of that black hole? What kind of reality exists beyond that ultimate boundary?
Or, thinking about that participatory universe, how does our very act of asking these questions, of seeking knowledge and observing the cosmos, how does that itself shape the universe we end up perceiving?
Definitely some heavy stuff to ponder. We hope you keep exploring these fascinating ideas. This has been quite the deep dive. And the journey of discovery is really just beginning.